Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5. It says a 12 kg block is initially at rest at point A at the bottom of a rough incline plane. The block is pulled up the incline by a constant force F acting parallel to the incline. The block reaches point B, which is a vertical height of 4.5 meter above the horizontal with a speed of 2.25 meter per second. Then 5.1 says define the term non-conservative force. So how do we define that quickly? We say a non-conservative force is a force for which the work done in moving an object between 2 points depends on the path taken. So that's how you're expected to define this according to your CAPS document for 2 marks. Right. Then 5.2 says draw a label-free body diagram for the block when it is pulled up the incline plane. Right. So note that it is on the incline. So the first thing that we're going to do is we try to faintly draw the incline so that all our forces are correctly placed. Remember that you're going to have to erase that incline afterwards. Then we have acting perpendicular to the surface is our normal force. And then acting downward is our gravitational force. And then acting up the incline is our applied force. And then acting down the incline, that becomes our frictional force, right? And then now you can nicely just erase that incline. And then now you have it like that. Or if you choose to draw the one that is resolved, so you choose to resolve the components of weight, then that means you have the normal force here. And then straight in line, you have the FG perpendicular. Then up the slope, you will have your applied force. And then down the slope is your FG parallel, which is another component of weight. And then down the slope again. So let me just make this dot bigger. And then down the slope, you'll have your kinetic frictional force. So you can either draw this one or draw this. So when they mark there, four marks, 4 forces, that's 1, 2, 3, 4. But when they mark this one, it's 1, 2, and then the components here, they amount to 1 mark because this is 2 components that represent the same force, which is the gravitational force. Then that's 1, and then 4 marks in total. So whether you draw this one or that one, they are both correct. Okay, so 5.3 says calculate the total work done on the block by the non-conservative forces when the blocks moved from point A to point B. So now we are being told to calculate the total work done by the non-conservative forces. Now, the energy principle that we're going to choose for that one is obviously the work done by non-conservative force formula, which is equals to change in EP plus change in EK. Now, it doesn't matter whether you start with change in EK and then you say plus change in EP. It's all the same thing, right? Then you just say W and C. So you won't break this one down because they are looking for the work done, right? So that means you'll just break this one here. So that's mg, height finally, minus height initially, plus half mass Vf squared minus Vi squared. So we have our mass as 12, and then we have our gravitational acceleration of 9.8. The height finally, remember, it's from point A, from a 0 height all the way to 4.5. So that's 4.5, and then initially the height was 0, and then we have half. Our mass is, so we have our mass as 12, and then our final velocity, remember they say it reaches point B at a speed of 2.25. So we have 2.25, but then square, and then our initial velocity, remember, initially at rest. So the velocity initially is 0, then square that. Now that's equals to W and C. Now your W and C, if you punch all that into your calculator, you end up with 559.58 joules, rounded off to 2 decimal places. So that's your 4 marks there. So I guess they will mark 1 for the formula, and then maybe substitution into the formula, and then a mark for the correct answer. Okay, so now let's now proceed to 5.4. So 5.4, it's saying the same constant force F now moves the block at a constant velocity. Note, it's now moving the block at a constant velocity. We know that constant velocity is assigned with acceleration being 0 meters per second square. And if we are to use our Newton's second law, we know that this will make our F net to be 0 newtons. And then if F net is 0 newtons, that means W net will also be 0 joules. So whenever you see the term constant velocity, always think of those three. Acceleration is 0 meters per second square, F net is 0 newtons, and your W net is 0 joules. Then across a rough horizontal surface, from point B to point C as shown below, then force F acts parallel to the horizontal surface. So we have our force now here, our force diagram now at point BC, which is a horizontal surface. And then now they're saying the magnitude of the constant frictional force acting on the block while moving from point B to point C is 42 newtons large. So now they're not saying the FK is 42 newtons. They're saying it's 42 newtons larger than the magnitude of the constant frictional force on the incline. Now we know it's a common sense that the frictional force in here is much smaller than the frictional force on a horizontal surface. So the more the more the angle on your incline, the less the frictional force. And then if now the angle is just 0 degrees, because the angle is 0 degrees on an incline, then the more frictional force that we have. Hence, we are being told that the frictional force from point B to C is 42 newtons larger than the one here. So if we can say here we have FK1, then that means FK2, friction number 2 at this point, would be written as FK1 plus 42. So whatever value that we have for the friction here, what we know is that between point B to C, it will be 42 newtons larger. So let's say for argument's sake, let's say maybe we had 10 newtons as our friction here. That means the friction in between B to C will now be 10 plus 42, which would be 52 newtons. Right. Note that we are not being told that it's 10. We are just making an assumption. So, okay, let me erase that because we don't know the magnitude of the frictions. So, okay, let's now start. Let's start by tackling from point B to C. So from point B to C, we can use our F net to say this is F net is equals to MA. And then since we know that acceleration is 0, this will just become, remember, if we were to draw a free body diagram from point B to C, this is basically what we would have. Our normal force, and then down here, our gravitational force. Then we would have our force applied. Then here, this would be our kinetic frictional force. Now, because this is moving at a constant velocity, we will then say F minus FK2, because this is friction number 2, is equals to the mass times the acceleration of 0. Then that's F minus FK2 is equals to 0, right? But then note that we said that FK2 is similar to FK1 plus 42. So let's just go ahead and say F. Now let's start by transposing that one to that other side. So that F is equals to FK2. Then our force will now be FK1 plus 42. That means we can now have this one as our equation number 1. So let's say this is equation number 1. Here, So we have the force is equals to Fk1 plus 42. What I just did here is to change the Fk2 and express it in terms of the friction number 1, right? So friction number 1 plus 42 is the same as friction number 2. Okay, so now we are done with that. But then coming here, we were calculating the total work done on the block, and then by the non-conservative forces, we can observe that we have two non-conservative forces here, which is the force applied, the applied force, and also the frictional force. Remember, we have three non-conservative forces: is the force applied, the frictional force, and the tension force. We do not have the tension, so the only two non-conservative forces that are here are the force applied and frictional force, right? So note that from 5.3 we had WNC is equals to 559.58 joules, right? But then we are saying the total work done by non-conservative forces is comprised of the work done by the force applied plus the work done by the frictional force 1, which is on the incline between A to B. Then this is 559.58. Now we can further break this down to F delta X cos theta plus Fk1 delta X cos theta. And then that is equals to 559.58. Now if we substitute into here, we don't have the delta X. So that's going to be delta X because we are not shown the displacement there. That's cos. We are not showing the displacement here. We are also not showing the displacement there. Now, we know that the force applied is always in the direction of the displacement. So that means we'll have an angle of 0 degrees there. Then we have Fk1. Again, we don't have delta X, but we know that our kinetic friction is always acting opposite to the direction of the displacement, so it will take the angle of 180 degrees. Then equal to 559.58. So this, the cos 0 is 1, so we'll only be left with F delta X, but cos 180 is -1, which we're going to end up with negative Fk delta X is equals to 559.58. Now at this point, we can see that our delta X now becomes the common factor. So we have delta X. This is the common factor here. So that means we can factor out that common factor. So we will have delta X is F minus Fk1 is equals to 559.58, right? But then now, how can we make this? How can we manipulate equation number 1 to be similar to this? There's something that we can do here. If we can take the Fk1 and bring it over to the left-hand side. So if we continue further with this one, that's F minus Fk1 is equals to 42. Now you can see that we can replace the F minus Fk1 here by this 42. So let's say this is still equation number 1. And then this is equation number 2. So in the place of F minus Fk1, we can replace by 42 newtons, which we can put in here, right? So this means that we're going to end up having, so allow me to just continue with the solving here. And then that means we will have delta X. Now remember, we are replacing F minus Fk1, which is what we got in equation number 1, by 42. So now we have 42 equal to what? 559.58. Then we can divide both sides by this 42. Divide by 42. Then our delta X right now has to be equals to, if you punch that in your calculator, that's 13.32 meters. And that's how you were supposed to solve that question for a total of 5 marks. So I know that you said this was a bit unfair with the marks, but then you know it is what it is, guys. At the end of the day, you were just supposed to know that and be able to calculate that. So make sure that you practice this question. In case something similar appears, now you would have already gained the experience into solving such questions. So with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.